Um, Welcome everyone. So we're going to start the workshop. So this is the second Learning from Imperfect Data workshop. And my name is Kyle, also known as Shuai Zheng. So I'm going to start the opening remark. So this workshop is organized by myself, Yun Chao, Miming, Han Zhao, Li Wei, Erwei, Yi Yang, and Antonia Toraba. So welcome everyone to participate this workshop and also challenge. So first of all, we want to talk about the motivations of this workshop. As we may know, like the problems we're facing often in the computer vision is we don't have acquired enough amount of perfect annotations. For example, the bounding box for object detections, the pixel-wise mask for semantic segmentations. So it's already very hard actually to train the reliable models given the perfect annotations. Not to mention in the real world, we often have the challenges that we cannot actually even collect the perfect annotations. I'll give you examples here. Imagine you have semantic segmentations that achieve above 80% mean intersection over union performance on the benchmark dataset. That doesn't necessarily mean that the models you trained, it will not mislead the self-driving car crashed into a flipped over track, because as you can see that a lot of images that we collected doesn't have the top of the images as a part of the scenes. So usually the cars has certain appearance. So back to the 2006 and 7, Mahiro had a presentations about learning with the imperfect data. So basically there's an ideal machine learning problems where you have IDD assumptions, where you have the SAM distributions of the data from the training and the testing. And then the distributions of the data may be fixed over the time. But in the real world, what happens is that the sample points are not drawn from the IRD assumptions. For example, you have lots of images and that are sampled from the same video sequence. And then you got the training samples that is very biased. In the case I just showed you before, you collect a lot of images that don't contain the car crashing or maybe the car flip over. So on the other cases, like the training points, there are often a lot of uncertainty with the labels. For example, you want to do the semantic segmentations task, and then you draw the polygons around the objects, but then you realize that the polygon is actually far from perfect, and it doesn't even cover the subjects you are interested in. And then sometimes you may only have the image levels labels for the object detections. And then maybe sometimes, people do make mistakes and you will, have the labels that actually got mistakes. So this makes it very difficult to actually train reliable models. And then you also got the problems that often you have multiple training sources that, when you want to make your data set bigger, so you combine the multiple data set together for training. And that creates the challenges that your models may not be good enough to actually learn all the informations. And then maybe the data is actually are too different that, it's very hard for you to actually train reliable models. And also the distributions may drift over the times. The famous example is that, when you're training character recognition models on the MNIST dataset, and then suddenly you got a very different type of numbers or very different type of alphabets, and then it could cause you, it could cause the models actually fail completely. So in this second learning from imperfect data challenge, so we focus on the specifically on the weakly supervised learning, which refers to we're trying to address the challenging patterns task by learning from the weak or imperfect supervisions. So for examples, we have the challenge that focusing on weakly supervised learning for semantic segmentations. we also have the weakly supervised learning for scene parsing and also for object localizations. So this workshop is organized to basically to focus to investigate the current method of building the industrial levels AI system relying on learning from the imperfect data. So the first challenge I want to introduce you. So this is the weakly supervised semantic segmentations. It's also known as track 1 in this challenge. So the original dataset is actually coming from the ImageNet ImageNet dataset. So we augment the ImageNet dataset by adding by including. So this dataset basically is built on top of the object detection track of the ImageNet dataset, which already have 400,000 training images from 200 categories. So we provide the pixel levels annotations for 15,000 images, including 5,000 and 10,000 images for the validation and the testing, respectively. So the supervisions in the training is image levels labels, which is not perfect. So usually you have the object detections that are trained with the bounding box annotations, and then the target is basically in testing is you perform the pixel-wise classifications, semantic segmentations. So the key evaluation metrics here, we adopt the standard semantic segmentations metrics, mean, intersection, over union. And then the other challenge is for scene parsing. So this dataset is built on the ADE 20K dataset. There are 20,000 images in the training set, 2,000 images in the validation set, 3,000 images in the testing set. So we provide additional point of annotations on the training set. So in this dataset is a little bit tricky because 1 pixel's annotations for each independent instance. And then the target in the testing set phase is basically you perform the pixel-wise classification, scene parsing, and then the key evaluation metrics here is also mean intersection over union. So we also got the weakly supervised object detections task. So this dataset is also built on the ImageNet dataset, including 1.2 million images for training. And we annotate a pixel level mask of 44,000 images for validation and testing. So this is basically to facilitate the whole evaluation. So for the supervisions in the training, we have the image levels labels. For the target in the testing phase, we have, so you have to highlight the target objects in the class activation map. And then the key evaluation metrics here is peak intersection over union. So the challenges attract many participants. In particular, in the track 1, we have 10 participants. As you can see, the winner here is the solutions from Sun Guolei, and then Wang Wen Guan and Lu Wanko from ETHZ. And then we have 1 participant in the track 2. This track is actually a very challenging track. So we have the winners from Tsinghua University, Hao Zhao, Min Lu, An Bang Yang, Yi Wen Guo, Yu Rong Chen, and then Li Zhang. So we also have the 5 participants in the track 3, which is the weakly supervised object localization challenge. So we have the winner here from Seoul National University's Vision Learning Lab. So the first winners, they are Wu Haobei, Junyong Nao, and Jin Wang So, and Guang He Kim. So the winners of each challenge is actually will present the method in this workshop later on. So here's the list of them. So I'm going to announce the Best Papers Award. So after reviewing all the submissions from each individual's team, so the organization committee decided to give the Guolei Sun, Wen Guang Wang, and Lu Wango the Best Papers Awards of this workshop for the papers mining cross images semantics for weakly supervised semantic segmentations. let's join the congratulations to them. Okay, so the sponsors of this challenge, thanks to the Baidu and the Pata frameworks, so they provided the cash rewards to the participants who actually released the code. So here's the list of the invited talks, and then the first talks will be Professors Alan Yu from Johns Hopkins Universities, and his talk title is "You Only Annotate Once or Never." So let me switch to Alan to present the talk.